All right, now welcome back. Like I said, we were going to do before, we're going to revisit the problem that we started before when we did the law of sines and realized we don't got enough information. So now that we got the law of cosines, and again, we're just looking for this angle measure here. We're trying to find angle P. So we're going to say that angle P is going to be our isolation. So that means the 6 feet has to be the one that's going to have to lead us. So we're going to take the formula a squared is equal to b squared plus c squared minus 2bc cosine of a. And this a is really standing for angle P. All right, so we're going to kind of substitute our values in. With the b squared and the c squared, they can go in any order. So I'm going to tell you to go 6 squared is equal to 20 squared plus 24 squared minus 2 times 20 times 24 cosine of P. Now, a couple things we need to kind of think about when we're doing this. This is like a coefficient, or a constant. So we're going to take the 20 squared and the 24 squared, and that's a set number that's been provided to us and that we can calculate. And then this 2 minus times 20 times 24 is your coefficient on your operator. So I kind of want you to think about this problem as like 6 is equal to 8 plus 2x, where the x is really standing for the cosine of P. So in order to solve for x like you do in a linear question or a linear problem, you subtract 8 and divide by 2, and then you get your value. And we kind of did this with chapter 6 by substituting the trigonometric functions with an unknown variable, and then putting it back in. The similar idea, because we kind of want to find what 20 squared plus 24 squared is. So we want to know what that set value here. So we got 976 is equal to 36 minus, sorry, I'm drawing a blank here, minus 2 times 20 times 24, which is 960. 960 cosine of P. So our goal right now is we need to get this isolated. So that is treating it like an x. So you subtract 8, divide by 2. So we're going to subtract 976 to get negative 940 is equal to a negative 960 cosine of P. Divide by negative 960. Divide by negative 960. And you get a decimal of 0.9792 is equal to cosine of P. And I don't want you to worry about if this comes out to be negative here, all right? Because that's not a big deal. The one case I've always been telling you guys is kind of stay away from those negatives because we're always looking for the reference angle. But in this case, we're not finding the reference angle. We're finding the exact angle measure of P in this case. So with that said, now since we're looking for an angle, we're going to do cosine. Oops, let me rephrase that. We're going to take arc cosine or cosine inverse, arc cosine of 0.9792, or cosine inverse of that angle. So it tells us that angle P then is going to be 11.7 degrees. So the only way that that puck in this scenario is going to make sure that hits the net in terms of this position, where he's 24 feet off the right post and 20 feet off the left post, so he's closer to the left than he is to the right, is if he shoots a puck less than 11.7 degrees. Because as soon as he goes more than 11.7 degrees, it's either going to A, miss here, or B, it's going to miss here. He needs to stay in the range of 11.7. And then as soon as you have this angle, we can plug that in there. And let's just say I want to find, let's say angle A. Well, now that you have an angle and a side that matches, and an angle and a side that matches, we can just go ahead and do law of sines. Sine of question mark is equal to over 24 is equal to the sine. Oops, I am getting lost here. Oops, I need my eraser. Apologize for that. We're on our third video, obviously, today. Sine of 11.7 over 6. Because now that you've found the angle measure, now we can just cross multiply and like do what we did on law of sines. So really, law of cosines is a formula to get us to law of sines, just so that we have a side angle side relationship. So the only thing that would change if I want to find angle A going law of cosines is that the 24 then would go in first spot, angle A would end it, and then the 20 and the 6. So I want you to kind of think about that these two sides are the two sides that form the angle that you're looking for. So B and C are forming the angle that's given. That's the easiest way, the best way to keep those in mind. Keep in mind, at any point you guys can pause, answer questions, kind of talk things through. So, all right, let's jump into our last example, kind of just make sure we have this. I'm trying to give you guys a lot of more applications right away, just to kind of get you started. When it comes to your homework, there's not any applications on it, just more of making sure you understand the process, the concept. I'm leaving the applications for a little bit later date and whatnot. So here we go. An architect is designing a kitchen for a client. When designing a kitchen, the architect must pay special attention to the placement of the stove, sink, and the refrigerator. So we're just going to make that X, Y, and Z. In order for a kitchen to be utilized effectively, these three amenities must form a triangle with each other. This is known as the working triangle. By design, the three parts of the working triangle must be no less than 3 feet apart and no more than 7 feet apart. Based on the dimension of the current kitchen, the architecture has determined that the sink will be 3.6 feet away from the stove, 5.7 feet away from the fridge. So we're going to underline that. We're going to underline this and say the sink will be this far away from the stove, this far away from the refrigerator. If the sink forms a 103-degree angle with the stove and the refrigerator, will the distance between the stove and the refrigerator remain within the confinements of the working triangle? So again, our confinements are right here. They're no more than 7 feet apart. So 3 parts of the triangle must be no less than 3 feet and no more than 7 feet. So let's kind of just draw a picture here. So we're going to say the X is the stove. And then we're going to draw we'll put Y down here, which is the sink. And we'll put Z over here, which is the fridge. So our working triangle. Obviously, the picture doesn't need to be drawn to scale. We're just kind of figuring out, what does this look like? What's the options? So let me make this triangle a little better here. So we're going to say X to Y to Z to X. So we know that the dimensions of the current kitchen, that the architect has determined that the sink will be 3.6 feet away from the stove. So 3.6 feet away from the stove. And the sink will be 5.7 feet away from the fridge. So check, we got that marked down. Check, we got that in our picture. We're hoping that this distance right here has to be between 3 and 7. So far, we're good. 3 feet, it's more than 3 feet. 5.7, it's less than 7, but bigger than 3. Now, if the sink forms a 103-degree angle with the stove and the refrigerator, so a 103-degree angle with the stove and the refrigerator, that's the angle that's being between here. Obviously, the picture's not drawn to scale, as you can see. I'm looking for, will the distance between the stove and the refrigerator remain in the confinements? So in other words, does this distance, which is, we'll say Y, fit between 3 and 7? So since we have a side angle side relationship, we got to use law of cosines. and we're going to put our angle y, our side length y. So y is going to be isolated, so y squared equals the two side lengths in any order that you want, 3.6 squared plus 5.7 squared minus 2 times 3.6, 5.7 cosine of the 103 degrees. So now I'm giving you the angle, unlike we didn't have before. So kind of just to keep track of our information, since we're going to do a lot of these, let's find this value first by taking 3.6 squared plus 5.7 squared. Gives you 45.45 minus 2 times 3.6 times 5.7, and you get 41.04 cosine of 103. And a healthy habit is to get these numbers here, because now it's just a matter of manipulating everything. You can go ahead and say y squared is equal to this. You can now go ahead and plug this whole thing in to your calculator exactly the way you see it there, of 45.45 minus 41.04 cosine of 103, hit enter. And you get y squared is equal to 54.68. And now we take the square root. So second square root of that answer. And we get y is equal to 7.39 feet. And now just analyze your answer. Since the distance between the stove and the refrigerator needs to remain the confinements in this current layout, the way he's going to do it, is he going to be greater than 3 feet? Yes. But is it going to be less than 7 feet or no more than 7 feet? The answer here is no. So in this design, he would not be able to keep his working triangle based on the dimensions that he has. Now, if he changes the 5.7 feet, maybe moves the fridge up, and obviously it's going to change the angle at which we can do this. So we could turn around and say, at what angle does he have to do in order to stay within the confinements? And then you plug 7 in there and work through that situation. Now, you guys probably think this question is weird, but as soon as I got this question, I actually thought about my house at home. My sink, my stove, and my refrigerator are actually in a triangle, and they actually do fit within this confinement. So if you kind of want to think about your house or your apartment or the place that you're staying at, just overall think that. Maybe, is this true, is it not? It's kind of an interesting situation, and I'd have to ask an architect if that's truly how they work it, but I do know that every house that I've thought of, my parents and mine, they do have the working triangle. I'm guessing it's more of efficiency with it. So the big question that always comes up is why? Why law of sines and cosines? This is just one case. A lot of it has to do with spotting. So triangulation is the process of finding coordinates of a point and a distance between the point by calculating the length of one side of the triangle. Given the measurements of angles and sides, the triangle is formed by one point to two other known references. Weather spotters can determine the location of tornadoes. Or the surveyors that just created this big bypass over the Bear River, they did the same thing. They had 3 spots, and they created the distances between them and to know what angle, what bigger gap, how much room to be covering. Because obviously, you're not going to run into a tornado. 2, you're not going to scale the length of the Bear River to try and figure out distances. So we can use law of sines and cosines for all of those situations because we're using non-right triangles. So I hope this notes worked. I hope everything is going well. I hope you guys are understanding the process. Your homework will be worksheet 7.4, day 1. And then the sub will let you know if I do any pick and choosing or if I just assign all of them. This will be due your next class period, which will be Tuesday, April 10th. And as of right now, if everything goes well with my wife's surgery, I will be here that day, so I'll give you guys some more feedback and some reflection. So I hope things went well. Feel free to review this. Feel free to, go back and look at things, read things, look over. Talk to you then. Bye.